Hey friends, welcome back to the first AutoML package. Now here I'd like to give you an introduction to AutoKeras. So maybe you have heard about Keras, you probably have, which is a deep learning framework which is built on top of TensorFlow. Now TensorFlow is the probably most famous deep learning framework which is currently out there. It's developed by Google and it is actually quite complex if you start coding in TensorFlow directly. That is why Keras was developed, which reduces the complexity and takes away some abstraction from TensorFlow. However, Keras still forces the developer to write a lot of code and also repetitive code. Because in Keras you basically have two different kinds of APIs. The one is the sequential API, the other one is the functional API. Let me just paste the sequential API as an example here. So that's what it would look like. So you basically define your model and then you import Keras, and then as a sequential API use a sequential class, and then within the class you define certain kinds of layers as well as activation functions for the layers. So this is the normal code you would write for different kinds of networks. In this case it would be a convolutional neural networks for image classification, but that's how it works in TensorFlow, Keras. So in order to avoid writing so much code for the network itself and also to do the pre-processing steps, remember that, and so on, name implies the automation of Keras. That's what it should do. Now let's actually explore this. So at first we need to install it, of course. So if you use Colab, you can do it like I do here with the exclamation mark and then type in pip install AutoKeras, like that. So, and let me run this for now, and let's just install AutoKeras here after connecting to it, to the specific environment here. If you do it locally, then of course you could use your local pip manager and install AutoKeras there as well. However, as a general recommendation from my side, if you want to do this locally on your local devices, then I would recommend creating a virtual environment for that, instead of installing everything in the same environment, which would be your base environment. But again, it's totally up to you whether you want to do this or not. So let's just wait. It should not take too much time now here, because Google download is quite fast. Locally, of course, it could take a little bit more time. So the installation is succeeded. Let me just scroll down and see everything seems to be fine. Okay, and we are done. So now it's available, and I can now actually comment this out directly. So let me just put in a hash symbol in before. Let's run this again so we don't see all the additional information here. And then let's import it. So I say import AutoKeras. And then we also need pandas just to load some data. So import pandas as PD. Okay. And then I need to also upload the files. So again, I'm using here, for instance, from google.colab import files. Let me just run this. Okay, and we import it. And let me just go a new code cell here. And then let me just upload the file. So call up is equal to files.upload. Let's run this, in this case here, inside, and then choose the insurance here. Click on open. And we are uploaded this. And then of course I could either go again to my folder here in files and then just upload the file here like that. Or I could also run the same code line again and then choose another file and go to my wine file in this example. Click on open and upload this as well. Let me just close this. So the files are there. We can easily check this running the ls command, ls, and we see exactly the files as well as the sample data folder, which is there by default. Okay, so then let's read the files one more time. We go with wine. Wine is equal to pd.read csv. And then we go with the wine.csv file. Of course, if you do locally, you need to point to a specific folder you have the data downloaded from the resource section. And let's call wine.head. And let's run this, and then we should see the first 5 entries. By the way, if you specify the amount of rows you would see then. So let's do the same for the insurance file. So say insurance is equal to, and let's call this pd.read CSV. And here we use the insurance.csv file. And also let's print out, just make sure that it's available for us. So insurance.head. Okay, so we got this as well. One thing I like to point out here directly is, remember that normally neural networks can only deal with numerical data. Now, for the wine data, for instance, we can see we get a lot of numbers. And just in case you want to make sure that this is not a string which just looks like a number, you could search for the dtype attribute to figure that out. But the quality here, as an example, currently is bad or good. So it is a text string actually, right? It's not a 1 or 0. It's not, so far it's not encoded using the label encoder, for instance. For the insurance file, for the regression problem, on the other hand, we have for various features which are also not encoded. Like normally for the pre-processing step, when we want to feed this data into a neural network, we would do some kind of, for instance, one-hot encoding for the sex column. So to have female as 0 and male as a 1, for instance. And also do something kind of similar for other columns like smoker here or region. Because neural networks can't read, in this case, text or string data. They need numbers. But I leave the data as it is now. And what I do is I simply split my data into training and testing. This is something I have to do to use AutoKeras. So I can say from sklearn.model selection, I want to import, in this case, train test split. You can also do it manually, but there's this convenient library here, so we can use this directly. Let me just go down here. And then I could say, for instance, that in this case, my X or my feature, in this case, would be all the columns beside the last one. The quality is actually the target we want to have, so we can split the data like that. And I could say actually something like directly xtrain, comma, xtest, ytrain, and ytest. You're probably familiar with this. If you've done this a few times in the past, then you can say train test split. And then basically I only need to give it the data. And here I could say for, let's say we start with the insurance, I can say insurance.ilog. ilog allows me to specify here the number of rows I want, let's say all the rows, and all the columns until the last one. So this means all the features, basically all the columns without the charges. That's what we select here, because this will be our X value. And then I can also do the same for the last, for the Y value. It would be insurance, and then .ilog again. And this time I say all the rows and only the last column. So that's why I'm using a -1 here, referring to only the last column. Of course, you could also save this up front in variables and then use the variables in here. Could also be done. I just wanted to make sure that we be a little bit more efficient here and save some text here. Okay, so, and also, by the way, just annotate it like splitting the data set to train and test, for instance. You can, of course, write some annotations here using the hash symbol, which makes sense. So then we can easily run this like that. And next, I just want to apply now AutoKeras. So I say here, keras is equal to, and by the way, the name itself here can be anything. I just use keras here, but you can use simply any kind of keras AutoML, for instance, or anything you want. And I say here, this is actually in this case, the neural network learner, which I create. And I can use this doing a class, or using a class here, which is from AutoKeras, dot, and there are various classes. And one of them is the so-called structured, and there's a structured data classifier and a regressor. And I'm using the regressor because we have a regression problem with the insurance file. Because we want to, forecast numerical data. So then I only need to specify here the max trials, because here I can simply say how many trials do I want. And I specify 8 here, so it doesn't take too long. Just want to make sure that our training doesn't take hours. So you should maybe not use a number too high. But of course, if you want to get better, better training, then of course you can increase the max trials here. But this of course would also mean that you train a longer time. So that's it actually for instantiating that. And then we can easily call it normally with something like similar to scikit-learn. So simply by calling keras.fit. So we can call the fit attribute here, and then we can put in simply our x train and our y train, like that. And that's actually all there is which we need to do. And one last thing, of course, is the epochs. Remember, neural networks go through the whole training data, and they do it the amount of times we specify in the epochs argument. So that's why we specify also epochs here, and let's say epochs is equal to 10, for instance. Again, you can also try out several more epochs, but be aware of the time it takes longer then, of course. But that's actually it. So let's run this, and then let the neural network train. That's what it's doing here. And one more time, I'd like to highlight that what we basically do here is no data preprocessing. So that means we have here numerical as well as string data. We did not do any kind of scaling, which is also actually required for neural network. We simply use the dataset itself as it is. We say what is actually the value we want to predict, which is the charges here, and what are the features. We split the data into training and testing, and then we simply fit it into the Keras model here, and then it's running its trials. And that's all it is here for us to do. So this is definitely way less code and also way less preprocessing steps than you would have to apply if you use Keras. So we are done. That went quite quickly. And you can see here the trials. You can go through the trials here. You can see here the loss itself, the training, and everything inside, right? So after this, of course, the best, or in this case, the best hyperparameters, like the amount of neural networks and the structure itself, is all saved into, in this case, Keras itself, because we named it Keras here. And now in order to make predictions, it's kind of easy because it works the same way. You can enter a new line here and simply say, in this case, our predictions is equal to keras.predict, like that. And all we need to do is simply feed in the test data, right? So in this case, I simply say xtest, and then we have our predictions in here. And we can also we're done here. And just in case you want to see them, simply print them out. So have a look, predictions, like that. And then you would see here the charges as a NumPy array here. Then of course, and you can now do any kind of, metrics to, or see the metrics for the specific predictions. So for instance, from sklearn, I want to import the metrics argument, which allows us, or which actually, this library has various metrics you can track, like for classification would be F1 score, precision, recall, accuracy, and so on. And for, in this case, regression problems could be mean absolute error or mean squared error, anything like that. So let's import this. Let's run this. And so we import the metrics, and then of course we can easily check this. So I can say here, in this case, metrics dot mean squared error. So I can call them. You can see it here. For instance, as one of the metrics you can track, and then you can write in here actually the y test and the predictions itself, which you've done. You can run this, and then you would get an output in here for the mean squared error for that.